Hi and Assalamualaikum. My name is Nur Atisha binti Muhammad Roslan. So for today, we will present about road safety audit for ECG563 Traffic Engineering. Our group consists of 5 students, which is Nur Iliana, Nur Atisha, Nur Aini Shahira, Siti Haja, and also Farahana. What is road safety audit? Road safety audit, also known as RSA, is actually a formal safety examination of existing or future roads. It identifies potential safety issues and suggests improvement to enhance safety for all road users. It is essential during various project phases from planning to construction and also essential for enhancing overall roadway safety. This slide concludes that RSA is really important. Okay, here is our objective. First, to conduct a comprehensive road safety audit of a selected roundabout within the UiTM Shah Alam campus. Next, to address specific safety concerns at the roundabout and proposing practical solutions to enhance safety and operational efficiency. And lastly, to collect relevant traffic data and parameters to identify and analyze the issue. For our mini project, we have 4 stages. First stage is to determine the roundabout. We choose the roundabout near College Roger. Second stage is to determine suitable experiments and conduct analysis. We use spot speed study and also traffic volume study. Third stage is to identify road safety issues at the selected roundabout, and last stage is to propose solution to the safety issues. Okay, as you guys can see, for stage 1, we choose the roundabout near College Roger, and beside we have the design spec and geological layout. D1 for direction 1 from College Roger, D2 direction 2 from Main Gate, and lastly direction 3 from Gate 3.
The first method we use in this project is spot speed study. The spot speed study measures the speed of individual vehicles at a specific location under free-flowing traffic conditions. We use a laser gun and collect 100 data points per road, so we did on different time with different peak hour, which is at 8 to 9 a.m., 2:45 to 3:30 p.m. and 8 to 9 p.m. So this is the data for direction 1, which is from College Roger. So here is the frequency histogram for direction 1, which it shows the vehicle we're traveling for morning data is around 20 to 24 km per hour, while 30 to 34 km per hour for evening and night data is 30 to 34 km per hour. Next, the frequency distribution graph for direction 1. From this graph, we will obtain the mode speed from the highest of the curve graph. The morning data is 27 km per hour, while the evening data is 27 km per hour and night is 23 km per hour. The limit speed at the roundabout is already shown near the side of the junction. The speed limit is much not more than 35 km per hour. So from this cumulative frequency graph, we will obtain 15 percentile, which is reflect the behavior of slower moving vehicle. 85 percentile reflect the speed which the majority of vehicles operate under free flow condition, while 98 percentile shows the faster speed. Then the direction 1 data for cumulative frequency graph shows the morning, evening and night data, with 15 percentile is 15 km per hour, 19.5 km per hour and 18.5 km per hour, while 85 percentile is 30 km per hour, 34.5 km per hour and 35 km per hour, and 98 is 36 km per hour, 40 km per hour and 41 km per hour. And this is means the speed under 85 percentile is already exceed the limit speed, which is the highest is 35 km per hour, 34.5 km per hour and 30 km per hour for 85 percentile. Next, direction 2, which is from Main Gate. Frequency histogram morning show the highest traveling is around 35 to 39 km per hour, while evening is 30 to 34 km per hour and night is 25 to 29 km per hour. Then the direction 2 data for cumulative frequency graph shows the morning, evening and night data, with 15 percentile is 30 km per hour, 27.8 km per hour and 24 km per hour, while 85 percentile is 45 km per hour, 41 km per hour and 38.5 km per hour. and 98 percentile is 54 km per hour, 46 km per hour, 45.5 km per hour, and this is shows the speed under 85 percentile is already exceed the limit speed, which is the highest is 45 km per hour, 41 km per hour, and 38.5 km per hour for 85 percentile. Direction 3 from Gate 3 near Hotel UATM. Frequency histogram morning show the highest traveling is around 30 to 34 km per hour, while evening is 20 to 24 km per hour and night is 20 to 29 km per hour due to only two vehicles through the road at night. The frequency distribution graph for direction 3, the mode speed we get from morning data is 30 km per hour, while the evening data is 24 km per hour and night is 27 km per hour. So the direction 3 data for cumulative frequency graph shows the morning, evening and night data with 15 percentile is 22.8 km per hour, 15 km per hour and 19 km per hour, while 85 percentile is 34 km per hour, 27 km per hour and 23.5 km per hour, and 98 is 42 km per hour, 35 km per hour, 27 km per hour. And this is means the speed under 85 percentile is already exceed the limit speed, which is the highest is 34 km per hour, 27 km per hour for 85 percentile.
Next, we also use another experiment, which is traffic volume study. We decided to use this experiment to measure and analyze the number of the vehicles that passing a specific point on a road over a set period of time. This experiment uses the telecounter to record the volume of the vehicles. All the data is also collected and all directions are analyzed in morning, evening and also night. For the result, the PCU value uses are for the roundabout and each of the vehicles has different PCU value, which for cars are equal to 1, for lorries, big lorries and buses is equal to 2.8, and the motorcycles are equal to 0.75. In the morning, cars have the highest percentage value for traffic volume in PCU per hour with 80%, motorcycles has 50%, and buses has 5%, while the lorries and big lorries has 0%. For calculation of the peak hour factor, the hourly volume needed to be divided by 4 that had multiplied with the peak volume. The peak hour factor for the direction 1 is 1.93, direction 2 is 2.39, and the direction 3 is 0.99. For the design hour volume, the hourly volume needs to be divided by the peak hour factor. And the design hour volume for the direction 1 is 244, direction 2 is 172, and the direction 3 is 220. Average daily traffic of morning is equal to 26,424 vehicles per day. And lastly, the direction 1 has the highest value for the volume trend, followed by the direction 2 and then the direction 3. In the evening, cars also have the highest percentage value for traffic volume in PCU per hour with 72%, motorcycles has 27%, buses has 1%, while the lorries and big lorries has 0%. The peak hour factor for the direction 1 is 2.39, direction 2 is 1.91, and direction 3 is 1.54. And the design hour volume for direction 1 is 268, direction 2 is 132, and direction 3 is 28. Average daily traffic of evening is equal to 22,440 vehicles per day. And lastly, the direction 1 has the highest value for the volume trend, also followed by the direction 2 and then the direction 3. At night, cars have the highest percentage value for traffic volume in PCU per hour with 67%, motorcycles has 26%, buses has 7%, while the lorries has 1% and big lorries has 0%. The peak hour factor for the direction 1 is 2.09, direction 2 is 1.9, and the direction 3 is 0.75. The design hour volume for direction 1 is equal to 200, direction 2 is 80, and the direction 3 is 4. Average daily traffic of night is equal to 30,752 vehicles per day. And lastly, the direction 1 has the highest value for the volume strength, also followed by the direction 2 and then the direction 3.
Now, I will continue to discuss on the critical safety issues at the selected roundabout, where I will be proposing 6 main issues, which are cross-section and geometry layout, vulnerable road user infrastructure, roadside safety, road surface condition, street lighting, and speeding concerns. So for the first one, cross-section and geometry layout, as you can see from the video, we have observed that drivers often do not remain in their designated lanes when entering the circulatory roundabout. This is because we have noticed that there is an elevation changes at the entry points coming from the direction of College Roger. These elevation changes causes speeding vehicles to cross into adjacent lane as they navigate the roundabout. The second reason that causes the drivers to not remain in their position is because of the narrow lane width. And additionally, the faded lane markings also contribute to the confusion as drivers are unsure of which lane they should occupy. Next, we also must consider the safety of vulnerable road users, particularly students who need to access the staircase located near the roundabout. Currently, the staircase is situated on the opposite side of the road, and there is no zebra crossing nearby to facilitate safe crossing. This lack of pedestrian infrastructure poses a significant risk, as students may attempt to cross the road without proper guidance. Meanwhile, to enhance safety for these vulnerable users, we propose the installation of a zebra crossing near the staircase. This will provide a designated and safe crossing point for students, encouraging them to use the staircase rather than risking unsafe crossing. Additionally, there are paved footpaths provided for pedestrians along the side of the road, which can further support safe pedestrian movement if combined with appropriate crossing facilities. Next, the third issue that we are going to look at is road surface conditions. Regarding road surface conditions, we have identified poor drainage covers at the circulatory roundabout. The positioning of the drainage cover itself is quite critical as vehicles frequently pass over them when making turns, leading to wear and tear. This can also result in bent covers that do not last long and will be posing a hazard to vehicles. In terms of street lighting, we have noted insufficient illumination at the roundabout, particularly at night. This lack of lighting can create dangerous conditions for both drivers and pedestrians. Additionally, one of the street lights is also broken, further exacerbating this issue. Therefore, to address this issue, we propose installing heavy-duty steel grate covers. These covers will be more durable and better suited to withstand the constant traffic, thereby improving safety and reducing maintenance needs. Meanwhile, to improve the visibility, we recommend replacing the broken light and also installing additional street lights that meet appropriate standards for the location. For roadside safety features, we have also observed that there are no guardrails installed along the paved footpath beside the roundabout. Given the proximity of a dormitory for students nearby, this poses a significant risk as students may frequently be near the roundabout. And lastly, we have identified a speeding issue, particularly from the direction of the front gate of UITM. The straight road leading to the roundabout encourages drivers to maintain high speeds, and there are no interceptions to prompt them to slow down. Therefore, to enhance safety, we propose installing guardrails along the footpath. This will help protect pedestrians from potential vehicle incursions and create a safer environment for students and other vulnerable road users. And to mitigate the speeding issue, we propose installing speed humps to inform drivers of the appropriate speed as they approach the roundabout. This will help reduce the likelihood of speeding and enhance overall safety.
In conclusion, this project was done in 3 weeks at roundabout near the College Seroja in 3 different locations in the morning, evening and night. A spot speed study was conducted to enable us to understand and determine the speed distribution and key speed percentile of a traffic stream at a specific location using laser gun. This experiment was successfully conducted and both of the objectives were accomplished. The collected data allowed us to determine the statistical analysis that includes mean, median, mode speed, standard deviation, and standard error of the speed. Traffic volume study was conducted to enable us to understand and determine the vehicle composition in the traffic flow stream to observe the traffic flow trend and movement pattern and to estimate hourly volume and average daily traffic ADT. The traffic volume study provides valuable insight into the vehicle composition, traffic flow trend, and movement pattern at the location. According to the study, there is several types of vehicle such as car, motorcycle, and heavy vehicle with variable volume at different locations. We were able to monitor a peak traffic period and the general behavior of the car during the study period by observing the trend and movement pattern of the traffic flow. Overall, this study provides a critical foundation and encourage setting realistic speed limit, improving roadway safety and other for the safety of the road user. Besides, this study has accomplished all the objectives that are required